we have 3 nodes up, and I'm gonna show a picture of it as soon as I'm getting here. Okay, get this guy stacking. Picture looks like this. We have um, Opendaylight running my laptop, and I'm stamped out 3 VMs that I'm going to use as Openstack nodes. And these VMs are connected like this. I just have an internal network, 192.168.50, and dot one is the laptop. Laptop's interface, the host, and then this is how they talk to each other. Basically, we're gonna have the tenant VMs inside them like that, and they will be on their own overlay network. So as I'm stacking this, this is on the control node. It takes about 5 minutes, so that's why I wanted to get it started sooner. So while that's happening, I'm gonna go and start Opendaylight, and for that, pretty much gonna unzip it and enable L3 forwarding, like you see here. Install the feature for OVSDB OpenStack, and on this guy, I'm gonna actually have Wireshark running, so we can see traffic between tenant VMs once we get that going. Okay, phase one. I'm gonna put a filter here, so you would only want to see packets that are GRE. On this other control node, I'm gonna SSH to it. I'm gonna do a curl just to be sure that my capture is doing it right. Okay. So what I'm gonna do is create one tenant and 2 subnets like that with DHCP. So that's why we're gonna have a namespace for each DHCP associated with these. And then we're gonna create a router, which is a distributed router, OVSDB NetVert from ODL, which is really doing all the L3 in the ingress at the node level, which will also reply to ARP packets, which I will send a pitch in a second. And then this is the when we launch the VMs in it. And then for another step, I'm just gonna add some more VMs later to look like this. Okay. Okay. So now that we stacked here, I'm gonna go ahead and stack my compute nodes, and the same on the other compute node. And I'll go back here and I can look at the pipeline. This is the compute one. Same thing here, and same thing there. Okay, so now at this point I'm gonna go ahead and create the networks. Okay, and if we go back, pipelines, you see the tunnel interface. Okay. Okay, and now I'm gonna go and create the router and associate the interface to each one of them. As you can see, it doesn't really matter which node I do this on. I'm doing this on the compute 2 today. And now I'm just creating the 6 tenant VMs. So we have 1, 2, 3, 4, 5, one more to go. There we go. So here I can look at the namespaces. And I see the 2 DHCP namespaces in the control node. So let's get inside one of them. Okay. 10.1.1.02. So DHCP's IP address. Yes. Cubs win. And I can look at IP route. That's the ARP. So now let's go ahead and ping around. So this is pretty much gonna go in a loop, forever loop, and ping around. So you can ping not only the nodes in the one network, the 10.1, but also in the 10.2. So with that, I can come back here to the control node. Take a look at the pipeline for a minute here. So this is the table. Blog page I wrote actually talks to this as during a length, so I'm not going to waste too much time here. But you have the table 0, the classifier table, which is pretty much dictating if the packet came in locally or it came in from a neighbor. That's what these two areas are. These come from a neighbor. The tunnel ID matters. It's a segment ID, right? That's associated with that broadcast domain. The ARP entries. These are the ARP reply entries, and you can see more about how that works in this picture here that I have. And that based on a match of the tunnel ID and the IP it's looking for, it will move things around and basically turn the ARP query into an ARP response and send it right back where it came from. So with that, the ARP are all answered with, within the nodes that they started with. 60 and 70, those are the tables that are actually doing the rewriting of the layer 2 as the packet goes from one subnet to the other. And here, based on the destination and the source, so it would be at a source segment to that destination segment, you're rewriting the source MAC to match up the interface of the routing interface, decrement TTL. And on this table 70, you are pretty much taking the IP that you are trying to get to in a destination, and we write the destination MAC. So the router is not doing any ARP. It's actually it knows what MAC to go for, so it doesn't need to. And then table 110, which is basically two parts: the known unicasts, right, which is just the tunnel and the MAC, and you know exactly what port to go to, and that includes the tunnel ports, right? So if you look at the ports, the bridge ports, you have the GRE ports, right? And to know what port goes with what, you can actually tell from here. So this GRE to 22 is OpenFlow port 2. Port 5 goes to this MAC, which is probably the local the local VM. These other two are very likely there's another GRE and the DHCP. So you can see our ping packet coming around here. I guess I'll stop this so you can just look a little more. So basically, it's GRE. So you have the Ethernet over IP with the GRE label, and then you have a second Ethernet, and these are the MAC addresses that you would expect as the packet gets routed. All right. I hope you enjoyed this. Bye bye.